So what I've got here is the sample of people that they took. I don't know, it's about 10 people, and gave them a mild dose of the cold, and then they actually tested. They did swabs and tested how much mucus they were producing. I'm not sure if it was per day or per hour or how they did it, and they did that for people with the cold, with dairy and without dairy, because we're trying to disprove the wife's tale that when you have milk or dairy products when you have a cold, that makes phlegm build up. So this group here had dairy products with the cold. This group here did not have dairy products with the cold, and we're measuring some measure of mucus. So they actually measured the volume of mucus. So this is a scale that measures mucus, right? Okay. I probably should have, well, you have already done or made the call. Does anyone remember from yesterday whether it was too close to call, or you could definitely say that with dairy it was too close to call A, because 0 was included in the interval. Therefore, the true population mean, it's too close to say whether dairy has an effect on mucus while you've got a cold, okay? So you can't actually claim that having milk has any effect on mucus build up with a cold. I should have done that first in the video, but you've all seen the graphs. What this does, randomization testing, what it does is it reassigns all the categories. So if we're looking at, I can change it to median because that's what you looked at yesterday, and we're going to look at the difference between the two medians, between the two groups, but with reassigned values randomly. So record my choices. It's easier to show it while it's playing. Okay, so then it reassigns whether they're dairy or no dairy, and shows you by chance alone that there was an increase in mucus buildup between no dairy and dairy. If I do it again, randomly reassigning whether the person had dairy or no dairy, and by chance alone there was a decrease in the amount of mucus buildup when having milk or dairy products. Okay, so this is what would happen by chance alone. You don't know whether the person has been on dairy or not, and it randomly, you can see here what it's doing. This person didn't have dairy, but this randomly reassigned her or him as dairy. Okay, this, by the way, is not in the syllabus, but it's a bit of an extra to fill out your report in terms of having a good discussion about whether you can or can't make the call. So we can do that kind of multiple times. So sometimes they're negative, sometimes they'll be positive. There's a positive one. And what we expect by chance alone is a nice normal distribution graph of 0, because we'd expect that the mean of the difference is 0 by chance alone. Okay, so what we're going to see is the maximum possible values that we can get by chance alone. Okay, and each of the dots down here actually is recording a positive difference if it's on this side, or a negative difference by chance alone. So you can see by chance alone you could possibly get a difference of 10 between the two medians. The actual difference is 7.5 from the experiment, But by just randomly reorganizing them, you could potentially, it only happens very rarely, you know, was it this 10 times out of 1,000 trials did you get a difference of 10 randomly. So then what we can do is we can show tail proportion and put that 7.5 down on here, and you can see that you're saying from your sample that by chance alone 10% of the time you could actually get this difference. Can you see that? It's 107 out of 1,000 trials were on this side of 7.5. So about 10% of the time you could actually end up with this result just by chance alone. No assigning them to the group, just complete chance that the mucus did build up, right? Because that's what we're saying. With no dairy, there was less mucus, but having dairy intake with the cold, then there was a build-up of mucus. So this adds to the fact that there is no difference between taking dairy and having no dairy when you've got the cold. Okay, so you said it was the cool, it was too close to cool, and even doing the simulation by randomly reassigning your sample data, you could actually make this difference occur just by chance. The ones where you can make the call, this arrow will actually point way outside the normal distribution and say this is impossible to happen by chance alone, and that would be your conclusion.